we can take decimals, turn them into fractions, take those fractions, turn them into equivalent fractions. And here's the crazy part. All of those equivalent fractions that you create are going to be worth the same as that decimal value. Look, let's do an example. 7 over 10. If I was to turn this one into a fraction, that's in the 10th spot. So it's going to be 7 over 10, right? The first spot after the decimal is always called the 10th. So this is 7 over 10. Now look, turn this into an equivalent fraction. You're going to get, let's see here, we can double both of them, times by 2. That'll make 14 over 20. Now, I'm not going to show you all the steps in creating equivalent fractions. We did that in the last lesson. I'm just assuming you understand. 7 over 10 and 14 out of 20 are equivalent. And since 7 over 10 is decimal 7, that means 14 over 20 is also decimal 7 because they are equal to one another. Now, I can take 7 over 10 times it by 3. That would make 21 over 30. And guess what? If you punch this in your calculator, you're going to get decimal 7 as well. These are all equivalent to one another, and they were all worth decimal 7. That's called decimal equivalency. Let's do the second one. Tenths, hundredths. We have 26 over 100. Now, offhand, I could double this. I can go 26 times 2. I would get 52. I can go 100 times 2, and that would get me 200. And I can take this, divide it, and I would also get decimal 26, just like I did with this one over here. They are both decimal 26 because they are equal fractions. I can take this and times it by 3. I'm going to get bigger numbers. I don't want to do that right now. I notice right away, these are both even. I can divide them both by 2. Yes, let's do that. Let's go 26 divided by 2 is 13. And 100 divided by 2 is going to be 50. Look, 13 over 50 is decimal 26 because it is equivalent to 26 over 100, which is also decimal 26. Isn't that crazy? Look, 1.3. I have 1 whole and 3 out of 10. Now look, in my class, if you see a mixed fraction, always turn it into an improper fraction and then go from there. So 10 times 1 plus 3 is going to be 13 over 10. That's the improper fraction. 13 over 10 times the top and the bottom by 2, you're going to get 26 over 20. And that's going to make 1.3. Look, we can take 13 over 10 times the top and the bottom by 3. You're going to get yourself 39 out of 30. And that's also going to be 1.3. They are all going to be equivalent to one another. And you can keep going and make more equivalent fractions if you want. But I'm going to move on to the last question. We have here 1 whole. Now look, we have tenths, hundredths. What's after hundredths? Yes, thousandths. So we have 428 over 1,000. And remember what I said, always turn it into an improper fraction first. 1,000 times 1 is 1,000, plus 428 is 1,428. We're going to write that here. That's all over 1,000. You want to double this number here and double that? I don't want to do that. I notice they're both even numbers. I'm going to divide them by 2. That'll get me on the top 714, and that would make 500 on the denominator. Look, this fraction is 1.428. And this one over here is also 1.428 because they're equivalent. Isn't that great? Look, we're going to sort these fractions into the correct box. Go ahead and try it. I will advise you not to use a calculator because I'm trying to teach you to use the best calculator of all, which is your brain. But I will give you some tips here. Turn this into a fraction. Turn that into a fraction. Now ask yourself which of these match up with these two fractions and put them in the correct color. Go ahead, stop the video and try it. Okay, I'm going to go ahead and solve this now. You've pushed replay. 2 over 5, where does that line up with? Here or there? Now I'm sure you've recognized the 10 can become a 5 if you divide it by 2. And so if you divide the top by 2, you're going to create the number 2. Yes, look, you divide both by 2, you get 2 over 5. Haha, it works. We're going to leave it here. How about 6 over 15? Ah, no, that's going to be hard. How do you turn 10 into 15? What do you times it by? Well, we can add 5, right? No. You can't add anything to fractions on the top or the bottom. You can't do that. Doesn't create equivalent fractions. You have to multiply or divide. So 10 into 15, that's kind of hard, isn't it? We have some decimal number. How about this here? Yeah, I know, equally difficult. So you know what? We're going to put it on the side. We'll leave it to the end. We'll probably figure it out then. How about 41 over 50? Does it match up here? What do we times the 10 by to turn into 50? 5. But if we times the top by 5, we don't get, that gets us 20. That says 41. So it can't be with this one. How about if we put it over here? Look, 100 divided by 2 is 50. And 82 divided by 2 is 41. It works. So it goes here. 8 over 20. Very clearly over here, we have 10 times 2. 4 times 2, it works. We're going to have 164 over 200. I think we see the pattern here. Double the 100. Double the 82. It works. Now the 6 over 15. That one bothered us at the start. But you know what? I can't match it up with this one. I can't match it up with this one. But look at this. Since this is the same as that, and this is the same as that, they are all the same. They are all equivalent. What if I match it up with one of these two? Look at that. What do I times the 5 by? 3. What did I times the 2 by? 3. It works. Yes, it's equivalent.